Thank you for inviting me to SourceCon. I'm going to talk about automation and accessibility testing. Before I do that, just let me go very high level about what accessibility is. It's not about being able to access the application across the internet or something. It's really about designing and implementing your digital content or experiences so that users with any permanent or situational disability can fully benefit from digital content and or experience. And obviously, some disabilities are permanent, like somebody may be blind, but then there may be a situation where you're in bright sunlight or you're in a loud bar, and as a result, you cannot see or hear. And that's an example of a situational disability. So there are really three core concepts of accessibility. It comes down to be perceivable, operable, and understandable. Perceivable is all about, can somebody absorb or detect the information that's being conveyed to them? And a good example of this is an image. Is there a text alternative for that image? But it's a little more complicated than that, because you can't just simply replace the image or add to the image some audio which describes the image, because somebody may have multiple disabilities. So really, when it comes to perceivable, it's about making sure that all your semantic information and your information about meaning is, if it's visual or requires a particular sense, that it's also there in text, so that an assistive technology can pick that up and convey that to the person in the appropriate way. The second thing is operable. Can I actually press the buttons or the controls that allow me to experience the digital experience? And this is really about making sure that everything can operate with a keyboard, that keyboard controls can be reprogrammed easily so that they're not dependent on a particular device, and making sure that you're not doing device-dependent things like click down events and things like that, that you're using events that are can be translated to other devices, like a click event rather than a mouse down, for example, that sort of thing. And then the third one is understandable, which is a little bit more complex because it has to do with understanding, but it's about making sure that things are described clearly, that instructions are clear, that error messages are clearly presented in the application or the digital experience, that it's clear what the error is about, and that in general the information that's presented is at an appropriate level for the person that's consuming that digital experience. So obviously, you would have a different level of information for somebody who's doing a PhD. They need to understand a lot of jargon and a lot of symbols and other things that you wouldn't expect a normal kind of person off the street to understand. And the flip side of that is, if you're creating a website or digital experience for somebody off the street, you want to make sure that the reading level is appropriate. 8th grade reading level would be appropriate, for example, and that any jargon words are in fact described, or so that the person encountering for the first time can understand what's going on. So that's really what the three principles of accessibility are all about. And when it comes to testing for accessibility, obviously everything can be automated to 100%, but it's not always worthwhile to do that. In fact, Marcus Merrill from Source Labs, I like the way he talks about this, in saying that, you know, just because you can automate this doesn't mean you want to. Sometimes doing some things in a manual fashion is actually the most efficient way to do them, because you don't have to, especially if you don't have to do them all the time. But there are some steps that you take along the way to getting to that 100%. And one of those technologies is static analysis technology, which can get you up to 20 to 25% of that. Another one is dynamic analysis of the application while it's running, and you can get up to 57% of your accessibility issues can be found this way. And then there's tools that can help you with by assisting your manual testing, and these can get you to around 80%. And the good thing about all these tools is they don't require any special accessibility knowledge, and there's not a lot of effort to actually use them. And I'm going to be demonstrating some of these tools to you today. From a DevOps activities perspective, you can look at it from the individual, you can look at it from the team or the organization level, and really at all of these areas, you can plug in some pre-existing tools that can really help you be much more efficient. So a linter can be used, for example, while editing code as an individual. It can also be used for helping to gate code quality as a team. and reviewing your code. And then it can also be used at the organization level to monitor your code quality and technical debt. And I'll show you some cool ways you can do that. If you're using an API for dynamic analysis, you can write automated unit tests or end-to-end tests and embed it in that. You can you can test interactively with that as well. And you can run those same tests as a team to make sure that stuff isn't breaking your tests when it gets integrated into your source code. And then if you're testing interactively, as an individual, you can do that, or as a team, your quality team can use interactive testing to ensure your quality. And then finally, from a compliance perspective, you can set up some monitoring to report on your ADA risk. So let's have a look at some of the technologies with some demos. Okay, so I'm going to show you how the static code analysis works and how they can work both from the perspective of somebody editing their code, as well as from the organizational perspective, the team perspective, to make sure that bad code doesn't get in, even if somebody isn't really paying attention to what's going on in their own machine. And obviously, there's more options that you have here. I'm just going to show two of them. I'm going to show editing in the actual editor, the linter stuff coming up. I'm going to ignore it. I'm going to create a commit, and then we can see what we can do on the GitHub side with a GitHub action, simple GitHub action. So here I am. I'm in an example app that we've written using React, to show some this sort of capability. And what I'm going to do is I'm going to add into my user interface over here. I'm going to add a nice little link. So I'm going to have a link which goes to github.com, and I'm going to insert into that link a nice little GitHub image. And what you can see is, as I've typed that code into the editor, it's got a little squiggly underline, and it's the Axe linter is pointing out some problems over here. So the first thing is it's saying this link doesn't have a discernible text. Now, like with everything else that we have, I can click this link over here and it'll take me to information about that. I'm not going to do that right now. I'll show that to you later. But it's telling me that the links doesn't have any text, but it does have an image inside of it. So let me look at the error that it's showing on the image, and it's saying here, ensures that image elements have an alternative text or role of none. So what's going on here is that the image has an image file associated with it, but it doesn't have any alternative text. So that's causing both the image to error out and say there's no alt text here, as well as, because that's the only element inside the anchor, it's flagging the anchor as not having an accessible name as well. So, okay, pretty bad code, but as I type that code in, the Axe linter is helping me out and allowing me to fix it and giving me all the information that I need to fix it. So let's ignore that, commit that to the repo. As you can see, I'm on my sourcecon 22 branch over here. I'm going to do a git diff quickly just to make sure that my change is there. That's the change that I want. I'm going to say git commit -am hello sourcecon 2022. I always mistype sourcecon whenever I type. How's my code? How's my codes? And then I'm going to push that up to GitHub. And obviously I don't have that branch being tracked, so I've got to tell it to track the branch upstream. All right, so that got pushed to GitHub. So let's allow GitHub to do a little bit of its magic, but we'll go to the GitHub and we'll see there's now another pull request. Well, no, there's a branch. I'm going to create a pull request here. So how's my codes? Create pull request. And what we've got set up here is some actions that run. And as you can see, there's the end-to-end tests that are running. And I've got some accessibility stuff built into that already, but I'm not going to show you that. I'm going to show you some API stuff using the mobile APIs, but it's very similar to what you can do here with React and with HTML. But this is now running. This linter action is running in the GitHub action, and we'll get some feedback here very soon that'll allow us to, okay, there it is. So the GitHub, the linter failed. Obviously, it's going to find those issues. What I can do is I can click on the source code, the change source code, and the way we've set this particular GitHub action up is it's actually inserting comments here right into the code. So I can see there's an anchor and it's saying link name ensures link of discernible text, and image alt ensures image elements of also text of or role of none or presentation. So it's giving me all that information inside this pull request. So if I go back to the pull request itself, I can actually then set it up so that I'm not able to merge this pull request or approve this pull request until this issue gets fixed. So that's a very easy way to set something up once in your repository. Doesn't matter what the developers do. If the developers don't have the linter set up in the editor, if they use an editor that's not supported by the linter, you can catch those issues with zero effort right when they push the code to the repository before that code gets merged into your main branch and becomes part of a problem for you and your customers. And with that, I'm going to move over to the next demo. So I'm going to show you now how you can use one of our APIs to do testing both during the development lifecycle and something that can be then embedded into your regression tests so that it can be run over and over again. Now, the automated testing, as I talked about earlier, catches somewhere up to 57% of the issues, depending on your exact platform and what sort of tool you're using. I'm going to be using iPhone, iOS today, because I would like to also show you this integrated into the Source Labs real device testing capability. So as you can see here, I have my application with some of my tests set up, and I'm running it in the emulator over here. I'm just going to close the emulator. Just wanted to show you that. So now the emulator is closed. And you can see my Source Labs dashboard, and you see I ran some tests a couple of minutes ago or some time ago. So now what I'm going to do is I'm going to run my tests that I have here from the command line using the Source Labs source CTL, and we have a shell script. And this is very much similar to what you would do if you were running a build, say in your CI/CD process. Is you would have the build process run as a shell script, and that would then build your application, upload it to the source infrastructure onto a real device or perhaps many devices, and run the tests in the cloud and get all the results back that you need from that. So here you can see it started my build, and it takes a little bit of time to do this. And what's going on is this is then going to get uploaded to Source over here, and Source is going to run the tests. And the tests that I have set up for this is set up such that it's not doing any assertions on the results that come back. So the results that come back, we're just going to be logging them into the DQ cloud service so that we can track them over time. And that's a use case that's very common for applications that exist before the accessibility effort begins. So what our APIs allow you to do is to embed calls to the analysis at the various different points within the user interface, and we analyze that application, and we send that off or generate a report that you can then view, that you can then share with the dev team. You can also do reporting over time on that to see whether you're getting better or worse over time. And it's a very common use case for teams that are not starting off their accessibility journey with a new application or from scratch, and allows them to then ensure that as they're building new code, that things aren't getting worse, and that over time, perhaps they're burning down and reducing the backlog of accessibility issues that they do have. So there we can see the tests passed. In this case, it's an XCUI test. And it's just a simple functional test, actually. So it's not doing a whole lot. I didn't want a test that was going to run for a very long time. If we come back into the source dashboard over here, you'll actually see that we're on the real devices. You'll see that this ran a minute ago. If I click inside of this, the nice thing about the source platform, for those of you who use it or don't use it, is that you can see a video of the application as it was being tested on this real device. So I can actually view the video. It's useful in particular if something went wrong during the application. So you can see it's testing the app over here. And then the analog to that is that it's also generated a set of issues inside the DQ reporting. So here you can see it's an iOS application. It was done a couple of minutes ago. And if I click on the number of issues that it found here, you get into the application which allows you to view those. So once again, you can see we capture screenshots for this, and you can see that there were 3 different rules that failed: one for active control name, one for touch target size, and one for supporting dynamic type. If I open up each of these, I can inspect the details. So very similar to what you'll see if when we look at the HTML tools and those capabilities. Because we take a screenshot like this, we can highlight the element on the screen that failed. So this active control name failed here for this input field, and it's saying, is accessibility focusable true? Is active control true? And the name is null. So there's no accessible name, which means that somebody using a screen reader on an iOS device, when they encounter this, it'll just read blank, input blank. Let's look at another one. We can open up this one, highlight that. You can see there's kind of a tabbing interface down at the bottom, and you can see that this tab control here also does not have an accessible name. So very useful interface for then inspecting this. There's also links that take you out to help pages for the particular issues that help you with what the algorithm is doing, what this issue relates to, who it impacts, and for various different languages, it gives you information on how to fix the issue, how to create an accessible name. So that's a very good example of how to use the APIs, very simple things to use. Embedding the API calls is just a simple 2 or 3 lines of code inside each of your tests. And then you can also do assertions on that. I've actually commented this assertion out. So the amount of effort to integrate this into your existing XUI test or something similar to that is really minimal. Okay, this next tool that I'm going to show you is a tool that is a browser extension. I'm running it here inside the source live testing environment. So I've set up a Windows machine with Chrome, and I've got the extension running in this, and I'm going to show you, do all my demoing of this tool inside this Source Labs environment. And this tool is very useful from multiple perspectives. So first of all, with a single click of the button, it'll run all the automated tests, and that can find up to 57% of your issues very, very quickly. But it also has built into it some semi-automated, what we call intelligent guided tests, which can do some of the things in an automation-assisted way, some of them using machine learning and artificial intelligence to help you do that more effectively. And that can support multiple different use cases. One of them is you're a developer and you're writing your code, and you can test while you're writing your code and fix the issues immediately, perhaps even build some of that into your regression tests so that you can test for that over and over again in an automated fashion. The second use case is if you're a QA tester and you want to test for some of those things which cannot be fully automated, and you're not writing full automation for all those accessibility tests, that's sometimes not worth the effort. Then you can use it in that sort of use case. And then the third use case is if you're doing exploratory testing, that you can do your accessibility testing as part of your exploratory testing. So for all of the reasons that you'd want to use something like this Source Labs environment to do real browser testing in the cloud, you can of course use the extension in those environments. Of course, you can also use it in your local environment as well. So it really supports any mode of operation. And what I've got here is an application that we've written for the purposes, once again, of demonstrating some accessibility issues. It's a recipe dashboard. And the way you can get started with this tool is you just click the Scan My Page button. And voila, after a very short period of time, it's found 12 accessibility issues. You'll notice that 4 of them are for color contrast, and you can click on any of the failed rules over here. It tells you how many of issues it found for each failure. And then you can do things like highlight the issue on the screen, move through the issues one at a time, inspect the details by clicking the inspect button, and it takes you into the Chrome DevTools where you can inspect the code to see what's going on, the generated code to see what's going on there. You can also get a lot of useful information by clicking the More Info button, and it'll take you to our online information. In this case, it's color contrast issue. And so what we also give you in this help page is a very easy, nice to use little color contrast analyzer. So you can actually look for other colors that might pass, or you can inspect as to how close it is to the actual the failure rate. And it gives you all the information about how to fix it, why it's relevant, what sort of users it impacts, and more. And so very useful information that's available for you to inspect and fix the issues while you're coding. So that was the fully automated test. Now, if I want to go further and do the intelligent guided test, I can just click intelligent guided test, and I can give my test a name. The reason you give it a name at this point is now you're getting to the situation where you have a lot of relatively large amount of effort put into the testing. So you want to make sure that you can save the results. Maybe you got to go away and do something else and come back later. So I can say, okay, this is my source con demo, and save that. And now it presents to me a set of tools that I can use to do a bunch of other accessibility testing. I've got a keyboard tool, which helps with keyboard testing, also for screen reader testing. I've got a tool that will help me with modal dialogues, a tool that helps me with interactive elements, things like buttons, links, etc. I've got a tool that I can use to evaluate the structure of the page, lists, images, and forms. So very useful stuff. Now, what a lot of these tools are doing when you run them, I'm going to run the keyboard tool over here because that's something that everybody knows about when they get started with accessibility, is that you need to make things usable with a keyboard. And what this will do is it will actually use real keyboard events, fire them against the page under test. And as you can see it on the left-hand side, it's going through all the keyboard focusable elements. It's numbering them. It's looking at their tab order. It's looking at their focus states. And it's looking at the information about how it's semantically marked up, and making sure that all of those elements on the page can actually be accessible, that are focusable, are accessible with a screen reader. So it's doing a lot of things that you would have to do with a lot of inspection or a lot of using of different screen readers on different platforms. It's doing all of that automatically for you. So this test is now tested for me to make sure all my buttons there can actually be used with a screen reader, and it'll do that for all the different platforms. So I don't have to go and run these tests again on all those different platforms. It'll do that analysis for me. So now the first thing it's asking me is it's asking me some questions about my application. It's highlighted all the elements that are tab focusable on the screen, and it said, are there any elements that you expected to be in the tab order but were not? So this is, if I'm the developer of the tool, or if I'm a QA person, I should know what should be interactable on this page. Is this button, is this number here something that you meant to click on to see something? And because I know the application, I can answer this and say, no, there's nothing that was skipped in the tab order. That's great, because using that information that I've just given it, it can now analyze the application and see whether there's an accessibility issue associated with that. So that's kind of the principle of this tool, is to ask you functional questions about the functionality of your application and combine that together with the semantic information that's there for the purposes of communicating with assistive technologies, and analyze to see whether your answers about the application match up with the way stuff is marked up. And now it's asking me about each of these elements. So it's highlighting the elements on the screen. If I mouse over each of these elements, it highlights it on the screen. So you can see here the grilled cheese little pencil button is highlighted now. And it's asking me, is this element interactive, or is the element a scrollable region, or is it neither interactive nor scrollable? So clearly this is a pencil icon that I'm supposed to click to get a little dialog to edit this, this card. So I'm going to leave it as at the default, which is this element is in fact interactive. And I can go through each of them. It'll go through all the pencil icons. It'll go through each of the buttons at the bottom and ask me these questions. And when I'm done with all of those, I can click the next button. And using the information and the answers I gave it, it's now determined that there are in fact 8 issues on this page. Now, for the astute of you, you'll realize that if I highlight one of them, there are 8 issues of the same type with each of these pencil icons because I'm doing this on a component. And I'll show you a little bit later how you can actually scope the test to just that component to say, I don't want to test each of these cards over and over again. I'm going to test one of these card components, and then that'll give me all the information I need to fix that card component, and then that'll carry over to all the other instances every time that's used. So I can highlight that. What it's telling me is the element's role is missing or not appropriate for the element's function. Let's inspect that and see what the issue is. And here you can see that instead of a button element or an input of type equals image, I've used, the developer has used a div with a tab index and obviously some click handlers and stuff like that to kind of implement a pseudo button of sorts. So instead of just using that built-in, some of the built-in components that HTML gives you, the developers, decided to implement their own thing here. Now, what they've forgotten to do, that would be fine if they implemented correctly, but what they've forgotten to do is they've forgotten to put something like a role equals button on here so that when a screen reader gets to this, the screen reader knows to allow the JavaScript events to go through and get passed to the JavaScript event handlers. So what we've detected here is a situation where a pseudo button is not going to work when a screen reader is turned on. And I didn't have to turn a screen reader on to detect that issue. So that's very useful, saved me a lot of time. I don't have to test with all the screen readers. I don't have to have different machine types with different screen readers on them to do all that sort of testing. So I mentioned before the demos that you could use a linter to get an idea across the organization of what your code quality is. And an example of that is to integrate it into a code quality dashboard like SonarQube. And AxeLinter integrates very easily into this. A similar thing to what you saw with the GitHub action. You can get the same information inside your SonarQube code quality dashboard. And the good news about this, it doesn't require any interaction from the team. You can set this up completely independently, pull down all your repos on a constant basis, analyze them every day, every night, whatever the schedule is you want to do that, and get an up-to-date report that gives you a good idea about trends. And another completely outside in independent way of getting a view of what's going on across the organization is to set up what we call a monitor scan, where you can set up URLs and applications with login scripts and dynamic scripts that execute your dynamic application. And while it's doing that, it can analyze those, can analyze PDFs and give you, once again, at any point in time, a view as to kind of what's going on in your organization, how good the accessibility is, and whether that's getting better or worse over time. A one-stop shop for all your accessibility testing is really the combination of Deque's tools and Source Labs' infrastructure. I showed you a bunch of ways today of how you can integrate the two tools and how they leverage each other. For those of you here today, we're offering a coupon code, SourceCon22, for 22% off your first online payment. If you go to axe.deque.com/plans, you can redeem that for yourself and or your teammates.